All right. Well, good morning, everyone. Sorry for being a couple minutes late here. I had some technical issues. I still have actually, but nothing that hinders me from doing a stream today and getting started and continuing working on this repo. So, how's everyone doing? How's your day so far? How's your weekend? Are you enjoying staying at home during the COVID pandemic, or are you like me, wanted to get out and see the world and travel again? I think we're all in different stages of this pandemic right now, but one thing's for sure, it's going to stick around for a while, so we better buckle down and just continue doing what we like and enjoy and take it from there, I think. So last week we went ahead and did a little bit of starting on the Kubernetes side of things, and unfortunately we had to cut that session a bit short, but we're going to continue working on it today and see where we go with the whole thing. I think one thing that I noticed so far is doing this is that it's pretty complicated to get this right, and I was trying to figure out some things this morning and I was still struggling with it, so I think we have to struggle with it together today during this session, but that's okay. I think we just have to keep hitting that wall to try to understand how things work and how things hang together, to understand how we can actually set this up and working in MLOps.net. And I think we're pretty close to kind of knocking through that wall, but we just need to keep knocking until we understand what's going on and not working. During the session today, I will probably kind of look into this book a little bit now and then, or Google things. So if I Google and look in this book, that's because I'm trying to learn as I go along. I have been reading this book on my free time. It's the Kubernetes Up and Running by Brendan and Joe and Kelsey. It's really good. I enjoy it a lot actually. I learn a lot about different things and thoughts on how to structure things, so highly recommend it if you are interested in getting started with this. But before we go into Kubernetes, I want to show one thing that's really cool that happened this week, that I think you can get a lot of use of as well if you want to contribute to a repo. So about 2 months ago or something, I signed up for the Codespace beta for GitHub Codespaces, and I just got approved for that this week, which is great. So we can actually go now, and I think it works for all of you because it's the repo itself here. If you go here on code now, you can actually go and open with Codespaces, and you can select the branch before, right? So if you want to use the main branch to develop on, or if you want to use your own branch, you have to kind of work with that a bit. But you can click on open Codespace, and if you don't have one, you can create a new Codespace right here. And if you have one, you can just pick one right here, and they are specific for your users, so I can't go into your Codespaces and vice versa, which is kind of neat. And you can personalize them a bit and do kind of stuff here. But what's happening in the background here is that GitHub is spinning up a Linux container with C# and .NET Core SDK and some other stuff kind of pre-installed on it already. And it's providing this really neat UI for Visual Studio Code with the branch and everything available for you. So you don't actually need to clone the repo locally, you don't need to download anything, you can actually develop everything as we go here yourself. So for example, we see here it's a little bit small. Let's see if I can zoom in for you. I think that's better. You can see here now that we actually open the repo and the source code here in online version of Visual Studio Code, and we can go into source here and we can see our projects, and we have all of these things that we normally see. You can go into our entities, we can edit them, and I also chose to enable personally for myself Docker extension, so I can run Docker containers in my container, which is kind of neat. So for example, if I want to spin up a SQL Server instance, or what else do we have? Some other blob storage fake containers for unit testing, I can do so here, and I can keep everything in the cloud. I don't need to do anything locally anymore, and it's really neat, I think. Really cool stuff. And as well, we have source control integrated, of course, so you can create your own branches again and check in open PRs and all that jazz as you would like to see. So that's pretty cool. I think it'll be useful for sure. Right now, at least, in the beta version, it's free, so you can use it as much as you like, and it doesn't cost anything. Let me just do one thing here. And that's pretty neat. And once they go out of beta, I think it's going to cost a little bit. We'll see if it's still going to be free for public repos. But even if it's not, it's still, I think, worth looking into and doing something about that. So definitely worth checking out. I encourage you all to do that and see kind of where it goes with that. Nice shade here. Trying to avoid the shadow that you're all seeing. Alright, so that's really cool. I wanted to show you that, and now I've done that. And what I want to do then is, well, of course, engage in the chat if you're there. It's always fun to talk to you all. But I want to show the GitHub issue that we're going to look at today. And then I'm going to walk through kind of how I want to try to solve it. And we'll see if I'm able to solve it or not. Let's see. Perfect. Go away there. Make sure I see the chat. So we have quite a few issues open here, and we are trying to go against 1.2, right? That's kind of the next release we're doing. And in that release, we're trying to support Kubernetes and Docker deployment. And we already can do Docker run, Docker build. We can do it, push it to a container registry wherever you want, really, which is awesome. So that's great. And one thing that AJ is currently working on, which I'm really excited about here, is the schema generator. So what he's doing right now is trying to decompile runtime instances of your model input and model output so that we can then actually generate C# classes that we can copy over into the folder that we will then compile to or build into a Docker image that we'll deploy to a registry. So I'm really excited to see that kind of coming together. That's a final piece of building the image itself. But today we are going to look at Kubernetes, and especially this issue right here, 305. So we want to deploy an image that's already generated to a cluster, and we have some ideas of how we want to organize that, of course. But I've been doing some research here the last few weeks here to kind of understand better how this works, because I'm not a Kubernetes person. I'm just getting started myself, and I want to kind of walk you through some of the thoughts here and how this kind of works, and then together we can see if we can figure this out, if you will. Alright, so Kubernetes, right? What is Kubernetes? Let's give a quick intro to that. So we have Docker images, Docker containers, and we can run them locally. We can run them in a Docker daemon, as we say. And for example, if we open up, just do the code here, we can see that we have a local registry, or we have registries that we connect to. For example, we have the Docker registry right here. That's my own public one, Islotte. And then we also use other ones, but we can also connect to specific private repos if you wanted to, and all those things. And you can connect to registries here as well if you wanted to. And we'll connect later to an Azure one. And then if you want to run them, you can actually go ahead and run Docker run here as well. So for example, we can see that we currently have nothing running, but if you want to run this predictor here, I can actually type Docker run Islotte predictor 1, and I think I need to specify the ports here. So we can say that please listen on port 5000 and forward that to port 80 in my container, which is going to be kind of the port that the application will be listening on. So we can see here we start this up, and if we open something like Postman here, let me go and pull this over real quick here. We can see that if we try to hit localhost 5000 here with /review/predict, which is going to be just an ASP.NET Core application controller that takes in a body of a review, and it's going to return true or false if it's positive or negative. So if I run that, I will get back true here. So it's a positive review. Maybe it's a neutral review, I don't know, but it's not negative at least. So that's awesome. That's kind of the way you can spin up an application locally, or you can spin up whatever you want really locally. You can hit that with a dedicated port that you've specified. And you can see it's running here. We can actually attach, if you view the logs here, you see that this is what's happened when we actually hit it. So if we hit it again here, we'll get, well, we should get the log here, but maybe we won't get it one time for this specific instance here. And we can inspect it as well, so we can look at the container and how it's defined, and we can see that it's running, and we have no specific checks for it to be running, but we have the image hash here and kind of it running on a Linux container, and we can look at this more in detail, and everything is declarative instead of imperative, so understand how this is configured. And generally we don't need to worry about all these details, but it's there if you want to, and that's pretty cool. We can also attach a shell here, so with that, what that means is that you can actually SSH into the container, so I can actually now execute commands in the container if I wanted to see how it's structured. So for example, if I run dir here in my working directory, which is the app directory for this specific container, I can see that these are my DLLs and these are the things I actually have in this container here. So you can see here that we have the model zip that we comment over, but we also have every other assembly that we need for this to work properly. So there's a way, you know, to actually go into the container and look what's underneath the surface and all those things. Pretty cool. So when it comes to, you know, actually deploying this production or using it in production, Docker is not really enough, even though there's something called Docker Swarm and other things to deploy to. And what people started using is something called Kubernetes instead. And Kubernetes is this distributed kind of computing platform where you can deploy your containers into a pod, or you can deploy multiple containers into one pod, depending on how you want to structure your application. So each pod is the smallest unit in Kubernetes, and you can manage those pods in multiple ways. So for example, you can create a replica set of them and say, I want at least 3 instances of this application running at any point in time. So you can, for example, think of that as running 3 VMs for your web app, right? And it's all behind a load balancer. And you want to make sure you always have 3 at each time, because otherwise you don't have enough failover or you don't have enough performance. The cool thing though is they're not VMs, right? They're just an abstraction of that. So it's much quicker and easier to just spin up a new pod than spinning up a VM. But the cluster itself runs on multiple nodes. And each node, I think, it's just a VM underneath the surface. So you're kind of taking that abstraction one level up, really. Anyhow, that's like what we want to do here is we want to be able to deploy our containers to a Kubernetes clusters in one way or another, so that we can then execute a command externally to do things. That's a lot of talking here. But you can actually run Kubernetes locally. So Kubernetes you can run locally on your computer, which is kind of pointless, but it's mostly for testing purposes. Or you can run it on the cluster itself, either locally or in the cloud. If you would do it in the cloud, you could do something like, let's see if I can get this reloaded again. You can, for example, spin up a cluster in Azure, or you can spin up a cluster in AWS or Google. So right now, I've spun up a cluster here in Azure called an Azure Kubernetes service. And at first glance, there's a lot of things here that it's difficult to understand what it's doing. But we can see here that we have Kubernetes 1.16 here as the version of Kubernetes. And Kubernetes is an open source solution, originally developed by Google. So you can kind of contribute to yourself. And we see we have one node pool, which means that we only have one kind of VM or computing part of this cluster in the back here. So it's pretty small cluster. It's this is the size of them, so you can define the VM size here. It's nothing powerful, but it's kind of going to work for us, at least for this test purpose. So namespaces is a way that Kubernetes used to kind of divide up different pods into logical groupings. And I'm still getting used to kind of what that entails, but I would imagine that we would do like a namespace for each experiment, if nothing else. Maybe even like experiment name dash test or whatever, if it's like experiment name plus the deployment targets. So we should think about how we want to structure that, but I think that's the way it's going to work. And we can see we have different types of system namespaces, and then we have like a default one that things end up in. Yep, cool. And we can look at this more further a bit later, but in general, this is kind of how it looks like. It's pretty cool. But what we're gonna do now is at least start looking at the local version here instead of the on the cloud version. So if you want to do Kubernetes locally, of course you need to install Docker Desktop here if you're on Windows, and you can do, I think, Minikube if you want to do it on like a Linux or iOS instance here. But if you haven't done Docker Desktop before, it's a great thing to get started with here. And I can go on settings somewhere, I think. Settings, right? And we can look at how we configure Docker Desktop to get Kubernetes running locally. Let's see. So this is kind of the thing you get here to configure Kubernetes. And we can see that we have actually Kubernetes tab here. So Docker Engine is easy, you can check the Docker Engine. You can update that pretty quickly. You have the command line CLI for Docker, Docker run, Docker build. You can enable experimental features if you want to be really cool. There's a couple I wish would be public already, but this is just if you want to. But then you have Kubernetes, and by default it's disabled if you have Docker Desktop installed. But you can just click enable here, and it's going to kind of kick it off by itself here. And you can see that we have both running right now, and you can reset it, do all kinds of stuff here, but this is where you would enable it locally. And if you want to, then you can also install the Kubernetes extension for Visual Studio Code, and you can kind of get a better idea of looking into namespaces and things locally here instead. So for example, we can look at namespaces, we have the default one, and that's pretty fun. But most people don't really interact, I think, with Kubernetes by using a UI. How can I get out of this one? Exit. Okay. Exiting out of this shell, hopefully. Let's see. So I think most people use the CLI instead to access this. Let's see, stop this one. Can I get back my terminal, please? There we go. Most people use something called kubectl. I'm sure there's a better pronunciation of this, or the way you say it. I call it kubectl. And that's kind of the equivalent to Docker, right? It's the Docker's CLI command. So you can use kubectl to interact with your cluster. Since we're using cluster locally here, we can run something like kubectl cluster info, I think, to get an idea of what's running here. So we see that we have a cluster running, and it's just running locally, which is awesome. And we can actually look at something like kubectl get pods, and what that's going to do is give us any running pods right now. So we have no resources found in the default namespace, so nothing is deployed yet to this. But we can do kubectl get nodes, I think, and we see that we have one node, which is my computer, which is good. So we don't have multiple nodes here by some reason. So that's pretty good. So how do we actually get something to deploy to, how do we deploy like an image to this cluster, and how do we kind of manage that? Well, we're going to walk through it a bit later, but I kind of created a simple file for the show, at least in the beginning here, and we're going to see if we can get this to work. And I've yet to get it to work, but I made sure to do a little work beforehand, so we get the most out of this session today at least. But deployments are done through something called like a Kubernetes manifest file, or a YAML file, or multiple actually, to be honest. And they are looking kind of like this, where you define an API version, yet to kind of understand. Well, there you go. Defines a schema of an object. So depending on the version here, I think you get different keywords you can use here to define your pods or application. And in general, Kubernetes uses declarative as opposed to imperative configuration. And declarative meaning that we're trying to define the state of where we want the pods and everything to be, or our system to be in, instead of having multiple like programmatic sequences saying deploy one pod, create one pod, and then have a for loop to making sure that we have enough pods, all that stuff. So we're trying to avoid that by just doing this instead. But the important thing here is the kind here. So we're trying to deploy a pod in this case, but you also have multiple other kinds here. Like you have You have like replica set, you have daemon set, you have deployment as a kind. So there's multiple kinds here, and they kind of all built on each other a little bit. But the smallest compartment here is pod, and to keep it very, simple, we're going to just do pod there. And we can name the pod something, so we can call it review predictor in this case, and we can give it labels, and label is the way the Kubernetes API tries to find pods. And for us now, this is just like a placeholder, but I envision this is going to be like experiment name eventually. We'll see. And then if you want to, you can specify, you have to do this, to specify the containers that we're going to deploy. So in our case here, we're going to say call this review predictor, and you're going to pull this image from my GitHub, my Docker registry, also there, and the name is predictor, and the tag is going to be 1 here. So this is a specific container right here that we want to get, and this is on my public repo. So it's not local; it's actually remote, but it's just public. So there's no login required, and we have to look at how we can manage login later. And if you wanted to, you can specify resources. So you can say, okay, this specific instance, don't use more than 128 megabytes of memory, and don't use more than 500 something of CPU. And then also in the fine and end here, we can specify the ports you want to expose on the pod's IP address. So for example, we can say port 8080 can be exposed to the world here. Hopefully that makes sense so far. So if you want to deploy this one, how do we deploy this to our local Kubernetes cluster? Well, so when we do that, alright, what it's going to do is Kubernetes is going to look at this image and then deploy it to a pod of our choosing and keep it up and running. So we can do kubectl apply, and that's kind of the magic command from what I've learned so far on just deploying pods and images to a cluster. And everything here is kind of deployed through manifest file, so you have to do the -f here, and then we will go ahead and say deploy YAML. And the reason why I can do that directly is because I'm already in this folder where this file is contained here. So we'll see we have this deploy YAML file here. Okay, and we'll see that, okay, pod review predictor created, that's awesome. So now we can do something like kubectl get pods, and we'll see that we actually have one pod there. So we have one because we only defined a pod, we didn't define a replica set. And it's running and has 0 restarts, and it's just up and running here. And I think we can do something like kubectl describe review predictor. Maybe I have to do a describe pod. Let's see if I remember the syntax correctly. Okay, that seems to be working. So we can try to describe it, and we can see more information about it here. So we can see here, okay, that's great. We have container ID, we have an image here. This is the image that it's using. This is the cluster ID IP that we currently have, and that could be useful, I'm not sure. So everything has a cluster ID, which is like an internal ID. IP. We see when it started, we see when it's using. We can see all kinds of fun stuff here. And do we see a namespace as well here? I think so. We have no mounts right now, so it's just kind of simple. Okay, perfect. So that's kind of running up and running, which is good. So what I was struggling with here before I started the stream today was trying to understand how we can access this one. So you saw when we did Docker run here, we can just do localhost 5000 and then review predict, and off we go, and it's just kind of working. And I'm trying to figure out how I can access this one, because I'm not sure which endpoint it's at and if it's available. And I think what we can do is kind of try to figure this out for a few minutes, and if we can't, we'll continue with some other things I want to show you as more of a introductory presentation. But this is kind of right now the stopper for me to continue to deploy it to the cloud. So let's Google that real quick here. So I have some ideas, I just not fully understanding on like how the structure is going to look like here. Accessing service on Kubernetes. So I think actually one thing, one thing if I Google this is like, okay, you can do localhost and a port and an API namespace, and our namespace can be default, I think, and then talk about this service here, and I am just really curious here about how this is actually working, because I don't want to actually access the cluster, I want to access my service specifically here. So if you are on a stream today and you have more experience with Kubernetes, I would very much value input here. .NET app in Kubernetes. Let's actually look at maybe see if we can find a good article here. That'd be great. We've done most of these things. This is a long article, that's great, because that hopefully means that we have something working soon. Web app, blah 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 blah. Docker files built. Don't see anything issues here. Pushed our image, running it, Docker run. And then I want to do, okay, so this is deployment files, this is good. Okay, probably can expose port 80 instead, but that's okay. Okay, so then we do the apply here, right? And so this is done somewhere else. What is the kubectl proxy? Let's look at that real quick here. Kubectl proxy. Maybe this is what I need to start here. So let's look at this. That seems like a lot of information. Don't want that. Okay. So I wonder how they got the public IP address here. This is kind of what I was interested in. So you see, I think this is the deployment kind here. So pod is the lowest level, and then we have replica sets, and then you can have deployment itself, which is more like manages that. So maybe we just need to update our YAML file here to be deployment instead, and then have a service on that, and that should be okay. I mean, that's interesting too. Let's actually change that. I mean, it's worth changing. I'm happy to follow these instructions because I am very much a newbie in this set, and it would be great if we can learn more stuff here. So let's go ahead, and what we can do is kubectl, and we can do delete pods, and then do all, and that's going to delete pods. And then if we do, let's see if we can get back to this one here, we have terminating. Okay, so you see the status terminating, it's going to go and get removed. That's all good. Alright, so let's go ahead and change this manifest file here and see if we can get a deployment instead. I think that's probably what we want anyway later on, so I'm not against doing this. And I think we can still do version 1 here. We can still do like review predictor for all the names here. And let's do 2 replicas for now. Actually, yeah, that's fine. Why not? I think we do still want, I think at the end we want 1 here, and then we want to change this as a configurable parameter for later here. So okay, we'll do a review predictor here. Great, and then that's good. And let's see what is going on here. Okay, so no, we can actually add back our resource limit here, because I think that's probably a a good practice to do, otherwise it will just kind of kill the cluster if you don't have that. Okay, perfect. Let's see. Okay, I think tabs are important. Let's skip that one. Oh, sorry guys, change the screen here. Okay, back again. Okay, we are learning on a job, right? Perfect, getting paid for that. If I was getting paid, that would be nice. Okay, so this is the deployment YAML file, and that's great. So let's go and look and change for a service. So service is a way to expose it as well here. It's like a load balancer that sits in front of your service and exposes it to the world. And I didn't think we needed one. Actually, I wasn't sure. But we probably need a service here to kind of expose it to the world. So let's do that. So let's do service. Watch where my fingers are. Service.yaml here. We'll go ahead and put that in there. We'll make sure we use the same name here. So this is a type of service, and the service itself is going to have a load balancer, and you can actually see here, we can read about it a bit. It's a named abstraction of software service. Consisting of a local port that proxy listens to, and then which pod to answer the request of the proxy, and. So that's great. And the reason why I'm getting this IntelliSense, by the way, is because I have a Kubernetes extension installed, which gives me a bit more information about how it should be structured and those things. So that's nice. Okay, so let's go ahead and apply both of these, and then see what happens. So kubectl apply deploy YAML. Sorry, it'd be file here, specific. Oh, okay. Okay, apparently we cannot do V1. It needs to have a beta version as well, I guess. Let's see. I'm curious about that though. Deployment kind Kubernetes YAML. I'm sure since 2018 this has changed to apps v1. Okay, so apparently it's like a apps v1 here. And it looks like this. Why is it not working? Kind deployment. Good. Let's see. I'm not sure why this is red, but we'll go ahead and continue and see if that is something that I actually care about or not. Validation errors. Okay, well it's nice that it shows me validation errors directly. Unknown field memory. Okay. So we have to do. Not caring. Okay. Let's remove this for now. I think that's okay. Something else is going on here though. Okay. So we need some kind of selector here, which makes sense. So we need labels for this. So I think I had that already, but let's see. I only have the name. Is that intended to go there? Yep, okay, perfect. So let's call this as nginx, however you pronounce it, is the load balancer here, but we'll just call it that. using field selector. Where do we have selector? Okay. We are learning on a job here. After replicas, we need selector. So we can skip the labels here. I don't think that's needed. And let's see, do we have something else going on here? Selector, match labels. Okay. And this needs to go in, I think. There we go. Now I think we're talking. Okay, perfect, that worked. And then we'll go ahead and deploy a service here, so we'll do service. Okay, so now if we go and do kubectl get calls, we should have 2, because we had a replicate of 2, right? That's what we described here, so we want 2 of them running. And we can probably go get service as well, and we'll see, okay, we have, this is the load balancer type here. And we're waiting for external IP here, okay, that's good. So probably once this is done, we should be able to access this one through a URL, which will be amazing and cool. Pending, let's wait for that a bit. Let's see what else it says. Okay. So wait for this to come up and running. We'll see if that works. So how's everyone's weekend going so far? How's everyone's day? Hopefully not too bad. Alright, let's go back and look here. Do we have... This can take a little while, I think. So port 80 is probably because we defined that before. So that makes sense. And I'm trying to find that URL. I wish that URL was there. Let's see. API v1. Cube system. Services. Okay. Services. This is an interesting URL. HTTPS Kubernetes dashboard. Okay, well, we can Google that in a bit here. Still waiting for that. Okay, let's Google this. Kubernetes dashboard. Proxy. Alright, so here we go. Start it up. Look at all the things we're learning today. Not bad. Maybe I have to wait for a bit. Well, maybe I didn't install it, who knows. Okay, run the following command. So it's not part of the default configuration, but we can get that working. Okay. Let's wait a bit for that one, I guess. Needs some time to start up. Okay, we can go in here instead into another command line, and we can look at get service. It takes a while to get this to work, I think. A little surprised that the external IP is taking so long. But it's set to wait, so... Yay, okay, here's the dashboard. Okay. So we have... where is the... So kubeconfig is the way we authenticate, by the way, to a Kubernetes cluster. And we will talk about that later once we go to Azure, but now we want to go to the local one here. So where's a local kubectl location Windows kubeconfig, sorry. Where is that usually under? User profile, let me open up here and go ahead and look for that. So it should be under my user profile. And cube. Okay, I see the folder. I see the config. Okay. Perfect. So it should be here. So that should be it, I think. Okay, not enough data. Let's look at that file. I feel like this should be plenty. But apparently not. Well, that is not great. Okay, well, I guess we're not going to do the dashboard right now, because that seems to be a non-great thing to do. And I wonder if this is going to actually occur or not, if it's something worth waiting for. Let's see, it was one thing I saw, by the way, that I wanted to check here. So in this case here, we are deploying this. It's deployment. I'm not sure if we need... Okay, let's try Postman here real quick, because I'm curious about this now. So we should be able to do service. Says okay, not available. But something like this, I think, is the way we're gonna access this one. kubectl get service. Okay. These pods are not accessible. They're kind of below the surface here, so there's no point of looking at them. We'll continue Googling, I guess. So this is kind of what we're trying to do here. We're trying to expose a service for our application here. So we have a pod and we have a service. A service in Kubernetes is an abstraction which defines a logical set of pods and a policy by which we access them. Service enable loose coupling between pods. A service running as a YAML file looks great. Yep, like that. So each pod has a unique cluster IP, right? And they're not exposed outside. Service allows the exploration to see traffic. Service can be exposed in these ways. in the service spec. Okay. Okay, that's good. So I think we're definitely on the right track here. And why don't we want this? Why is this not working? Okay. That is not helpful, so I'm going to skip that. But I'm a little bit curious about why I can't see this. I wish this would have been fixed already, and it's not. Can I access this one? Probably not. Well, it's taking some time at least, but it's not actually working. Kubernetes service locally. Windows, just to make sure. So we've done this. We've done this, right? So you can do no port is like without a load balancer, and we're doing a load balancer. So because we have more than one replica, but there are 2 ways to expose servers after load balancer. Okay, this is interesting. It only works with cloud providers, so that's probably why we can't get it locally to work. Let's try change this to node port instead here. I think that is better idea for this local at least. So we want to do delete deployments. And so that's the way to delete that. So we should also have no pods now, because there should be a cascading. Yep. This cascading delete is going to remove that. So let's go ahead and change this type here. So instead of having a service, like we can expose a service, but you can expose in different ways. A node port is the simplest way from what I've learned so far, and load balancer is kind of what we need if it's a multiple replica set. But we're going to just do a node port here, and port. Okay, let's kind of keep this, I guess. I'm not sure about the ports here. We want this one to be a 1 replica thing now, because we only have 1. The port on each node on which this service is exposed. So that's kind of, well, it's fine. Let's keep that if you wanted to, I don't care. Okay. So go ahead and apply this. So apply deployment, apply the service, right? And let's see here. We have 1 running because we changed it to 1 replica. Get service. And we have no external IP, and that seems to be okay. But how do we access that one? I think there's a comment here. Okay. You need to use the IP address of one of your nodes and a port from a field. Okay. So in this case, would it be localhost 5000 or localhost 3001, right? Because that's 30,000. Okay. Would that be the correct way of doing this? A socket hang up, okay. Or is it 8080? Okay. No, it's not port. So I wonder if we should change it to 5000, cause I think, or 80, because that's what it's listening on. But let's see. I think 30,001, right? It's interesting though. This is a different message than before, which is good. So one thing I want to try here now is I want to go ahead and delete this. I want to go ahead and do kubectl. Oop. Change this to port 80 because that could help, and then delete deployments all, reapply these, service, and if it doesn't work, I'm gonna check that. But you see that now we're exposing 3001, I think, and port 80 is going to be what's listening on below, which I think is going to work. Hallelujah! Look at that, guys. That is fantastic. You have no idea how happy I am about that breakthrough. Alright, so we knocked through the wall. We knocked through the wall. We have deployed our image here right now to a local Kubernetes cluster and exposed it through a service, and it seems to be working, which is fantastic. You can actually access it now, and we understand how this is exposed. So it's going to be, in this case, our node IP address, which is localhost, because we have that, and it's going to be exposed on 3000. So I want to change this to 5000 because that's more a standard port. And I think otherwise it looks really good. So I think we could do is a local a load balancer in the cloud to make sure we expose that more broadly, I guess, in some way. So it seems like we need two manifest files here for mlops.net. One that exposes the deployment here, and that's kind of pretty well done so far, and one that kind of wraps that deployment or those set of pods into a service that we expose to the world. So an issue right now, so now we've done it locally, so let's go ahead and level up here a bit. We want to do it to the cloud now, so we want to go ahead and do it in Azure Container Registry, because now it gets a bit more complicated. But I think we can manage it because we've already done so much already. So what we can do now, first of all, let's go ahead and let's see what I want to do first. So what I want to do is, let me type it up honestly, because I think that's easier for us to follow along here. And I'm doing this because this is going to be a more realistic scenario, so we need to understand how this works so we can just get it to work. So we want to deploy, or like build and push image to a private registry. So for example, what we're going to do here is an Azure Container Registry instead of our like public Docker registry that we can access without login. And then what I want to do is I want to run kubectl against Azure Kubernetes service and Kubernetes service, and I want to be able to deploy a private image to that service, and we can do it locally first and understand how that works. So that's good. So what we can do first is just let's go ahead and build this image here. And first let's go ahead and understand how we can log in here. I'm gonna just go ahead and I guess sign into Azure, so I can do it here. You can do it through Docker login if you want to, and log in like that to get access to your container registry. But I'll just do it like this for now. So it seems to update my password. Okay. Alright, so I should be able to access this now. Okay, so now you see we have a registry here, and we have a my experiments called MLOps.net. So I want to be able to get my same image I have to that. So we want to do a predictor here. So let's go ahead and say here, which is this is currently the folder where we have this review predictor in, and I think I can build this by doing docker build, but instead of doing view predictor for a slot here, I think I should be able to do MLOps.net here, because I should have logged in already here. And let's see if we want to build here. Okay, did it just work? You can check our local daemon here and see if we actually got something here. So I should have an MLOps.net. And I don't think I have one at least. No, here it is. Perfect. So an hour ago. Okay, I guess it's just a cached version. So now I want to push this one here to that library. So we can do docker push. I'm not sure if I need a tag or not here, but let's see. Okay. So I can't do that from here at least. I don't seem to be have logged in here properly. Let's see if I can do it from Visual Studio Code. So can I do it like push here? Yep. Requested service access is denied. That's right. I probably need to specify a better name for this service first before this works. So let's go in here and look at my resource group here. I should have container registry. So we need a kind of the fully qualified name here. So you see that we have the Azure container registry.io, just to kind of specify that we're going to Azure here and nowhere else. So that makes sense to be. So I'm going to go ahead and rebuild this. We can of course retag it, but I'm going to just rebuild it. Okay. And then I want to go ahead and push this. And the reason why it's so fast is because I kind of built it earlier, so all the dependencies are already there. Authentication required. Unauthorized. I feel like I just did that. Okay, what did I miss? Okay, here it is. Push. MLOps.net. Okay, well, it's doing something now at least here from. I guess I need to run docker login in the other command shell to be able to get it to work. But we're pushing, so that's good. Pushing it, pushing it, pushing it. Good stuff. I'm excited. We're moving forward, guys. I hope you're excited too. Alright, so we pushed that. Let's see if we can also see it somewhere. So if you refresh here, we have it here. So now we have the review predictor is pushed. So this like building and pushing can already be done by MLOps.net. So that's all good. So we're not necessarily looking for supporting that, but it's good. And I think if we refresh this, I'm not sure exactly where we will see our images. In the cloud here, overview. Not really sure where we will see this activity log. No. Where will you see this? Is it just like repos? Okay, here we go. So we see we have one here, and that is fantastic. And great. Okay, so now we want to deploy this to the Kubernetes running in the cloud here, right? So if we go back to our Kubernetes service here, how do we get it from the container registry to the Kubernetes service? And both of them are, requires authentication. So this is going to be a little more tricky. So first of all, what we want to do is we want to go ahead and update the image in our service here. So this is going to be predictor, I think, right? It's called a predictor. That's the image, I think, at least. Oh, we named it review predictor, okay. Okay. So this is currently my image name. And that's fine. And then if I go to my deploy here, I think that's also doing, well, that was my deploy, yeah. Okay, perfect. So if I do this now, first of all, like, how do we get access to, like, currently I'm just like running against, we need to be able to do kubectl apply, right? Otherwise we can't really apply this. So how do we even get access to the cluster in the cloud? That's kind of the first issue we have to solve here. And that's done through something called a kubeconfig. A kubeconfig is something we can define. So for example, we can do kubectl kubeconfig, I think. Let's do kube help here. And actually, you can probably do this if you want to. Kubectl kubeconfig view kubeconfig. Maybe else. But anyway, we have a kubeconfig, and we need to define a new one. So that one's going to define which cluster we're accessing and secret tokens that we need to access it. So how do we get one of those? Well, I did some research on that as well, and I think you can do this. So the way to export it is going to Azure Kubernetes in Azure Kubernetes service and running this here. So for example, if we go and open up here, I can actually start a bash shell here, or PowerShell interface here, and I can run this to get my kubeconfig file if I wanted to. So let's see if that works. It's going to initiate my shell here. Nice. Okay, so I always forget how to do this, but paste. So what we can do here is we can say, okay, resource group name. What is that name? Well, it's going to be MLOps net, I think, or ML container, something like that. MLnet container. MLnet container. And then my service name here, it's going to be MLOpsNet, right? So if I run this, I'm gonna get my credentials. I misspelled it. MLOps. That's right. Perfect. So what it does is it merges it into a file called kubeconfig, because that's what I named it. And you see we have kubeconfig right here, so we can do nano kubeconfig. We can look at it, and yes. And it has stuff here, and like it's a lot of yada yada. That's the access way at least. So let's exit that one. Regardless of that, I think I've downloaded it before, actually, like a day or so, just to try this out. So we have a kubeconfig here for Azure Kubernetes Service, so we should be able to use that one. So let's see if it's actually up to date, 'cause I'm not sure if it is. So we can do get pods here, and we can say kubeconfig And we can see here that we actually have one image still, because I tried this before and didn't get to work, so I'm still trying to get this to work. But what we can do at least is that we can go ahead and delete pods all, and that's deleted. Let's check the nodes here to make sure we actually are in the cloud here. So we can do kubectl get nodes, and you see if they specify this kubeconfig all the time. I think there's a way to set the context so we want to do that, but for now at least that's fair, I think. But as you see here that we actually are in the cloud here, so we actually are doing things in the cloud. But yeah, so we can try now if you want to. Let's try to apply both the deploy and the service here and see what's going to happen here. And I think it's going to fail, but I want to do it with you so we can kind of go through it all step by step here. So kubectl apply deploy YAML, right? That's going to be the deployment itself. That is to find the replica set and everything else. And you have to specify the file here. And then what we're going to do is we're going to deploy it as a service. So we're going to do service, define and expose the service. Okay, perfect. So no port here. Now we're going to go back to using something else. But we see actually we can, let's keep the no port for now, just to make sure. And that's probably why we have 30,000 here. Support range, and eventually I want to change the load balancer, but not right now. Perfect. Okay. So if you look at get node pods here, we'll see that an error image pool here. It can't necessarily get the image, and I think I probably should test this locally first, because we may run into other issues right now. But and actually we can do that if you want to. Let's do it real quick here. But the issue with pull the image right now is that we don't have authentication against Azure Container Registry. They don't necessarily talk to each other right now, so no one can really talk here, which is an issue. And how do we solve that? And I have, I think, a solution to that. But one thing I want to do real quick is to apply this locally, because I want to make sure that it still works. Because we should have access here already. Okay. Crash loop back off. Okay, so that's not very good. Something is going on here as well. Anyway, I think it's probably the same reason. We need to create a pool secrets, it's called. So I'm going to clean up here the pods here, and then we're going to look at that. Actually, it's kind of funny. So you see how I deleted these pods now? I promise you they'll be back. Yeah, so you see it is back. And this is kind of cool, right? Because I manually deleted the pods, but since we have the deployment object that lives above everything, it's going to manage my replica set and recreate them if I need to. If I want to delete stuff here, I need to go ahead and delete deployment instead. And now if I do get pods here, they should be terminating all of them. We're gone. Perfect. Okay. Pool secrets. Yep. So how do we go ahead and make sure we can authenticate? Well, it's something called a pool secret here. So we need to supply Docker user password name, blah blah. But we need this kind of. Eventually, we need to define this pool secret right here, and there is some documentation how to do that here. So we need to be able to get that pool secret, or we need to create a pool secret in Azure Container Service, and then provide a name to that pool secret when we deploy. So we need to create a pool secret in the actual cluster itself, and you do that by doing kubectl create secret docker registry. So then we give it the name. That's going to be the name we refer to in our manifest files, and then the namespace and username, password, those kind of things here. And in Azure, this is going to be like an empty GUID, because that's just the way it is. And then we can have a secret token here. And this is the name to the registry. So this is mlopsnet.azure.cr.io. So did create one before because I didn't want to go and create my secrets on stream. So we're gonna see if I get this to work. But we're naming it is the names with default. MLOps net I think is the secret name here. But let's go ahead and run this. And let's see where I want to run this. I'm making sure there's nothing I need to change here before I copy this over. Okay. We'll see if this works. It may not work, but we'll give us the best try here. So I'm gonna paste this in here. Okay. Okay. Well, that's not very good. So say my pull secret already exists, and it still didn't want to do what I was supposed to do. So that's probably an issue in general here that we need to solve. Can we actually remove this completely? kubectl delete secret. Okay, so now it's removed at least, so we can write this again. Oh, kubectl delete secrets all kube config. Kubeconfig. Alright, so now it's deleted on the server at least. Okay, so what is... Oh, I didn't... Oh, that's why. Okay, so I think it's probably actually gonna work. Probably was stupid for me to delete it, but let's add it here. Okay, so now we create the secret, right? So I'm not gonna go through all of it, but in general it's the same as you saw on the documentation here. So it's defining the namespace, which is default, and everything else here. So that is great. But one thing we didn't define, is probably why it failed, is because we didn't define in the file here. Let's go ahead and remove this. What the secret was. So we need to, in our service here, I think. Let's see, define pool secret in deployment Kubernetes. We need to do that. This is the secret, we don't really care about that. Okay, I guess it's just below there, so that's fine. So let's go back to our deployment object here and see. So we have the we define the image right here, and I think from what it says here, we want to do name. Well, probably should do name. Image pool secrets. Is that just like without a dash or with a dash? Let's do this. Just to make it more specific here. Name. View predictor. And you have to have everything in lowercase, by the way, Kubernetes, if you ever thought of that. If not present. Why do we want to work this way? Okay, so it's outside containers. That's one thing here. So we can happily do that. So I think it's going to be this level. No, this level. Image pool secrets. Containers. There we go. Perfect. And this is called MLOps net. right? So now we created a secret in the cluster, and we are defining that when you actually do this deployment, if you need to authenticate, here's the secret that you need to use. Alright, so this is going to be interesting. I have yet to get this to work, so I'm really excited here. So kubectl apply deploy YAML kubeconfig. Go to Azure. I don't know how many times I'm going to forget about the file attribute here. Okay. So we have an issue here, and it's probably because we didn't say name. Yep, figured. Is that going to be? Yep, it's going to be, I thought. Name. Okay, let's try it again. Okay, and then we'll gotta do the service. Okay. We already had a service. But let's see if we can access this now. kubectl get pods kubeconfig. Image pool backoff. Okay, I'm not sure what that is. This is the new one here. What is that even? So probably we defined the wrong image. I think that's kind of what is going on here. I'm trying to understand if that is the issue or not. I think we probably have to define a different image here. Can we start this one? Run. Let's see what it's called. Review predictor. Okay. So have we misspelled something here? Can I get the name? Actually, inspect. That's fine. Yeah, I know. Skip that, please. Remove. But I am curious about this one though. Copy full tag. That's great. Don't think anything has changed here really. I think that is the correct image. That is the correct image. I think maybe pool policy needs to change here. Let's see that. Just in case we have like kind of old one here. So let's go ahead and change that. And then let's go ahead and delete everything first. Delete deployment all. Okay. Service seems to be there regardless. So I think this is probably the most complex part of Kubernetes, is trying to figure out what is going on here. So let's go ahead and let's do this. Let's go ahead and create the secret locally, if possible, and then try to see if we can do this locally or not. And how would I do that? Well, actually let's see if Googling first can help here. For the secret, maybe we have a wrong secret here. Okay. So let me go ahead and see if I can... I think what's happening here is that we have the wrong secret. And I'm going to try to find the documentation to get that secret better. I think that's probably what's going on here. And did that. Because probably it's the service principal here is the wrong one. I probably used the wrong one by some reason, and I need to figure out. If you don't remember, or okay, so this is definitely. I got like a hash token here, so it seems to be a password thing that we need to do. Using existing service principal. Docker password. Let's see. Get Docker password to Azure Container Registry. I'm pretty sure I did this before. I just can't remember how to do this. New. Let's see here. Resource group subscription. There is something that I do not know. Okay, so let me run this in a separate prompt here. I think this is something that we need, is probably trying to figure out the correct token here. And I'm hoping it's going to be the same as we log in generally, because that's, if we do that, we can then build on that really easily in mlops.net here. So that would be nice if that worked. Paste. And let's see, what's the registry name here? One second here. To enable admin here by some reason. So let's do that. Okay, so that's interesting. I am definitely getting different passwords, if you will, than what I would otherwise. And I am a bit surprised here. I would have hoped that it would have been different. Okay. Like they are like very short and simple. So if you want to create one, you can do this. And you can modify that. So I was expecting it to be very similar to Docker login here, but that's obviously not exactly true. So that's, to me, it's surprising. Okay, that's fine. Let's try that at least and see. I mean, that's definitely, if it's working like that, that's okay. I'm okay with that. Let me modify my secret things on the side here. So the Docker username would be that, and then password. Let's try this first. Okay. I'm going to modify that. Well, it's a lot easier to read, but it's annoying if it's a different command, I think. Alright, let me run this here real quick. I'm sorry to pull the secrets away from you guys, but that's just the way it has to be. And what we'll do first is kubectl delete secrets all, and then do kubeconfig just to make sure we remove what we have, and then I will copy on this one and clear. Alright, so now I created that secret and it's there again, and let's see, was it the same user I expected? Okay, so let's see. Let's look at the cluster now again and see what we have here, what we have available. Get pods, kubeconfig. We have people running here, right? So we're going to go ahead and delete these. Okay, that's deleted. And kubectl delete service, kubeconfig. Probably didn't want to delete the Kubernetes service. Alright, we'll see if this works. Kubectl apply deploy YAML and remember file here, and we'll do kubeconfig. Okay, and then we'll do the service one. Okay, and now we'll see if we have something running or not. Crash loop back off. Still not working properly. Okay, well that's something to think about. I think this is a great stopping point for today. I think we've learned a lot through the session today, and I'm going to add a comment on this PR here that's something we're struggling with, and then that's something we can continue looking at separately. Had an issue with proper pool secret. It seems like that is different than the Docker plugin credentials. So I think in general, once we figure that out, we should have the necessary steps here to do all these things in ops.net as well, and use these kind of template manifest files and everything else to kind of just change things, and by then we can start building these out and add more configuration as well, so as a client you can kind of configure these as you like. But I think this is a great stopping point today, so thank you for listening in today and chiming in. And if you have any questions, any thoughts, or if you have any solutions to this, definitely reach out and I will be more than happy to receive them. But continue having a fantastic weekend, and we'll catch you all very soon. Bye-bye.